One of the most useful libraries in C++ is the Standard Template Library, or STL. It contains common programming data structures called containers, such as std array and std vector, which are able to store arbitrary data inside them, hence the word container. Let's get started with std array. As the name suggests, std array is a container representing an array, which is a fixed size list of elements that are all of the same type. We can make an array with the following syntax. Notice that we need to include the type and the size of the array inside the angled brackets. This is because std array is what we call a templated class. For example, we can create an integer array with size 5 by writing std array angle bracket int comma 5 angle bracket my int array. Or we could create a double array with size 3 by writing std array angle bracket double comma 3 angle bracket my double array. We can initialize std array with values at the time of declaration by putting them in curly braces. If we don't put anything inside the curly braces, then the array will be initialized with all zeros, as you can see in the example below. To access an element of a std array, we put the index of the element we want to access inside the square brackets. One important thing here is that this is zero index, similar to many other programming languages. What this means is that the first element of the array has index 0, the second element has index 1, and so on. So in the example below, we create an integer array of size 5, and we initialize it with the values 3, 1, 4, 1, and 5. When we access the 0th element of the array, then this corresponds to the element 3, as 0 is the first index. Similarly, if we access the first element, then this is the second index, and so this is the element 1. The last element in this array would have an index of 4, which will give the element 5. As we mentioned in last week's video about declaration, definition, and initialization, it is impossible to determine the element in an uninitialized variable, and this is undefined behavior and should be actively avoided. For example, we declare an uninitialized myUninitialized float array of type float size 8, and then at the bottom we try to access this using index of 3, but because our array is not initialized, the value of this cannot be determined, and this should be avoided. One important thing about std array is that both the size and the type of the array must be known at compile time. This means that we cannot use a variable as the size. For example, at the bottom, here we try to create an array of type int and size x, a variable. But because x is a variable, we don't know the value of x at compile time, and this does not compile. If we try to access the array with an index that is too large, then it is impossible to determine what value we will get back. And again, this is undefined behavior and should be avoided. For example, at the bottom, we declare an int array of type size 8 called myIntArray. And then we try to access the 8th element, which is 1 higher than the last element in this array, which has index 7. And because the index we're trying to access, 8, goes out of the array, the value which is returned cannot be determined, and this should be avoided, and it is undefined behavior. But note that this does not necessarily result in a crash. To ensure that we don't go out of bounds, instead of accessing elements with the square brackets, we can also use the .at method, which will throw an exception when you do go out of bounds. For example, at the bottom, we declare an array with type int and size of 8, and then we call the .at method with the index of 8 on our array. Because the index 8 points to the 9th element, which is larger than the number of elements that our myIntArray holds, this will throw an exception and our program will crash. Most of the time though, we do want to be able to tell if our index is too large. To do this, we can obtain the number of elements in a std array using the .size method. In the first example, we have a myIntArray with 5 elements, 3, 1, 4, 1, and 5. If we call a .size method on it, we get back 5. Similarly, at the bottom, with a std array with size 2, when we call the size method on it, it returns 2. Now, let's look at std vector. Std vector is also a container used for storing lists of objects, but as opposed to std array, std vector has variable size. This means that the size of the list can grow or shrink. The syntax for creating a std vector is similar to how we create a std array, where we write std vector, angle bracket, type, angle bracket, and put the name of the variable at the end. The main difference though is that instead of having to put both the type and the size in the angle brackets, we only need to put the type. And this is because std vector can be of any size. For example, here we create a std vector of type int and call it myIntVector by writing std vector angle bracket int angle bracket myIntVector. Initializing a std vector with values is the same as with std array. We put the elements inside the braces. However, because std vector is not fixed size, the size of std vector will change depending on how many elements are inside. For example, in the bottom, we declare a std vector of type int and call it myIntVector, and initialize it with the values 3, 1, 4, 1, and 5. After this, myIntVector will have the values 3, 1, 4, 1, 5, and be of size 5. As a result of std vector not being fixed size, we can add additional elements to std vector with the .pushBack method, which adds an element to the back. In the example below, we declare a std vector of type int and call it myIntVector. And then in the for loop below, we add all the integers from 0 to 99 into the vector using the .pushBack method. At the end of this for loop, myIntVector will contain all the integers from 0 to 99 and be of size 100. As you've seen from earlier, std vector shares a lot of the same API as std array, and this includes the square brackets to access an element inside the std vector, as well as the .size method, which returns the size of the vector. In the example below, we use the .size method to find the size of the vector right after declaring it, which gives us back 0. We then add in 5 elements, and then we call it .size again, and this gives us 5 as expected. We can also use the square brackets, so the 0th element is 3, the first element is 1, and then the 4th element is 5. We can also clear all elements of std vector with the .clear method. For example, we first create a std vector of type int and initialize it with the values 1, 2, 3, 4, and 5. Our std vector at this point has size 5. After calling the clear method though, our std vector is now empty with size 0. Now, on to how to iterate through a std array and std vector. One way that we've seen we can iterate through both std array and std vector is to use a for loop and iterate through the indices. This can be seen in the example below, where we create a std vector with values 1, 2, 3, 4, and 5, and then we create a for loop that loops from 0 to less than the vector size, and then we print out the index, colon, and then the element of the vector at that index. There's another way to iterate through these containers though, and this is what we call a range-based for. This iterates through all elements of the container without using indices. For example, for a std vector of type int, you'd write for parentheses int value colon myIntVector, and then in the body of the for loop, you'll have access to value, which will iterate through all elements of the std vector. Let's look at an example where we use both types of these loops. For example, if we're trying to find the average of a std vector of numbers, we don't need the index of a particular element. In this case, we can use the range-based for loop to make the function much cleaner. In the average function below, we first declare a double called sum equal to 0, and then we use the range-based for loop to loop through all the elements in the numbers vector, and then we add each element number to the sum, and then finally we return the sum divided by the size of the numbers, and then finally we return numbers divided by the size of the numbers vector. On the other hand, if we're trying to find the index of a given value, we need the index of the element, and so we need to iterate std vector with indices and a normal for loop. So in the example below with the find function, we create a normal for loop from 0 to just less than the numbers size, and if the ith element is equal to the number that we want to find, number to find, then we return the index I. Otherwise we return -1. So what are the main differences between std array and std vector? The main difference is that std array is fixed size and std vector is not. This means that you can add elements to vector through .pushBack, which increases the size of the container, but std array will always stay at the same size. If you know how many elements there will be, and that number will always be the same no matter what, then you can use std array. Otherwise, you should use std vector. And if you ever find yourself needing to make std array larger, that means that using std vector was more appropriate in that scenario. For example, I have 5 LEDs. Assuming that the number of LEDs is fixed, then it will be fine to represent them using a std array. Because the number of LEDs is fixed and won't change, then using a std array is fine, as we don't need to use the dot pushback method of std vector or increase the size of the array to represent 5 LEDs. For example, on the other hand, if I wanted to record the temperature every second, since I don't know how many total measurements there will be, we can use a std vector and keep adding the new temperature to the back of the temperatures vector.